All right, everybody, this is section R.3/R.6 exponents. Before doing this section in the homework, and before maybe even watching this video, if this is the first time you've watched the video, if you weren't at the live session, make sure you go to week 2 module, or to the module that I have it in. I have the 6 rules of exponents. And make sure you watch it and write those 6 rules down. So first of all, 2 to the 5th power, we're just going to put in our calculator. There's nothing here. There's no rule here. It's just 2 to the 5th power. So on your calculator, 2 raised to the 5th power. I hope everybody's really good with their calculator now. Oh, you get 32. Don't forget, 2 to the 5th power is really write down the base 2 5 times. That's what it means. Write down the base 5 times and then multiply that. And you get 32. All right. Rule number 2. Do you see the bases don't always have to be X? They can be numbers or anything else. When you multiply 2 numbers with the same base, the base stays the same. A lot of people will say, oh, 3 times 3 is 9. No. When you multiply 2 numbers with the same base and they have exponents, the base stays the same. You add the powers, the exponents, 6 plus 7, and you get 3 to the 13th power. Oh, no. 3 raised to the 13th power. And by the way, any number that you can do on your calculator, do it. 3 raised to the 13th power on my calculator is 1594323. 1,594,323. Anybody get something different, let me know. So you do want to work it out if you can. If the number's so large and your calculator can't do it, then we would leave it as 3 to the 13th. But our calculator can do it, so we're okay. Question 3, look at this one. We have 1, 2, 3, 4 numbers with the same base. They're all being multiplied. When you multiply numbers with the same base, the base stays the same. The base is y. We add the powers. Multiplying numbers with the same base stays the same. We add the powers. 3 plus 5 plus 7 plus 9. Y to the 24? And that's it. You can't do that math. Y to the 24 is y to the 24. We don't know what y equals, so it's y to the 24. So we are going to use every single rule of the 6 rules of exponents. And you'll see we're going to use it multiple times in one problem. Anybody have any questions? Just buzz in. Let me know what's going on. Hope you guys are awake. I had to be awake for this. Uh-oh. So, like I said, they're going to get a little more difficult. The interpreters are awake. Okay, so let's take a look. By the way, do you see this is, I can rewrite this problem. 4a means 4 times a to the 8th times, do you see, then there's a multiply, times 5 times a to the 7th. 5a is 5 times a. So we're going to multiply 4 times 5. You see, you just multiply 4 times 5, and you get 20. 4 times 5 is 20. Then we have A8 times A7. Well, they're two numbers with the same base. Base stays the same. You add their powers. So the answer is 20A to the 15. 8 plus 7 is 15. That's supposed to be a 20. Okay, so here we multiply the numbers in front, then we multiply the numbers with the same base. You can only multiply the numbers with the same base. 5 times a negative 3 is negative 15. Positive times a negative is a negative. Then we have n to the third times n to the fourth. Two numbers with the same base. Base stays the same. You add their powers. There's our answer. Number 6, the numbers in front are 2 and negative 8. 2 times, this is multiply. When you don't see anything between these parentheses, it's multiply. 2 times negative 8 is negative 16. Now I have a to the fourth, and over here I have a to the fifth. You see, it's all multiply. There's no add or subtract in there. It's all multiply. The base stays the same, a, and we add the powers, 4 plus 5. We also have b's, and you can only do numbers with the same base. The base stays the same. We add their powers, 3 plus 8. So the final answer here is negative 16, a to the ninth, 4 plus 5 is 9, and b to the 11th, because 3 plus 8 is 11. That's our answer. A's and B's can't multiply because their bases are different. Negative 16, a to the ninth, b to the 11th. Don't forget, you can use the notes that you take in your workbook on the test. Hopefully that comes in handy. Moving on. Number 7. I'm going to give you a second. Try number 7 and then see if you get the same thing I get. So negative 3 times negative 7, negative times a negative is a positive. Okay, Matilda, you got that part right. Positive 21. Let's see the rest. X3 times X4, X stays the same. We add the powers. 3 plus 4 is 7. You got that part right. What happened to the last part? Uh-oh. Anybody know what she did wrong with the last part? Yes, thank you. Don't forget, there's an invisible 1 there. Why? Why? Bases are the same. 1 plus 5 is 6. It's tricky because of those invisible numbers. I mean, there's a number there. It's invisible 1. Yeah, it's tricky. And I want to show you the difference. We learned, so we know this, x2 times x3, the base stays, when you multiply, the base stays the same, you add the powers. Let me try something. I'm going to show you something different. So we know this, x times x equals, don't forget there's an invisible 1. Base stays the same. The base stays the same, and you add the powers. 1 plus 1 is 2. X times x is x squared. There's an invisible 1 and an invisible 1. However, x plus x is 2x. That's what we learned last time. Remember, here there's invisible 1s here, and there's invisible 1s here. 1 apple plus 1 apple equals 2 apples. 1 apple times 1 apple is apple squared. There's still invisible 1s here, but we don't care about those right now. But when we're adding apples, we're talking about 1 apple plus 1 apple equals 2 apples. X times x is x squared, but x plus x is 2x. Trying to clean this up a little. There we go. So you see the difference between these two. It's really important. Let me clean that up. You really have to know the difference between x times x and x plus x. We talked about the apples adding with apples and subtracting. You add the numbers in front, but you can only add x's with other x's. Multiplying, when you have the same base, you add their powers. So it's different rules for multiplying and adding. And people often get these rules mixed up. That's why it's good to have your notes in front of you. And I allow it. So when you take a test, and when you're doing the homework, use that as practice. You know, making sure you can read your notes. Don't have test time all of a sudden is the first time you ever looked at your notes, because then you won't be able to find anything. All right, so this is a different rule. We don't have 2 x's this time. We have 1 x, but we have 2 powers. Power raised to a power. The base stays the same, but when we have a power raised to a power, we multiply the powers. See, that's different. We had 2 bases multiplying. The base stays the same. We add the powers. But here I have 1 base with 2 powers. We multiply the powers. All right. Power outside of parentheses attaches to each item in the parentheses. The 4 attaches to the 3. It attaches to the x, and it attaches to the y. This is the answer, but if you put it into the homework, it's going to be wrong, because any number to a power, you got to do the math. And 3 to the 4th power on my calculator is 81. So that equals 81 x4 y4. Telling you. So this is a lot. This is a tough section. The rule, you got to have those rules with you. You got to look at it. You got to practice it. This is a tough section. Power outside of a parentheses attaches to each item. It attaches to the -3, and it attaches to the x. By the way, you can put it straight to the x, but I just want to show you, there's an x with an invisible 1. It's the same thing. -3 to the 3rd power. I put this in parentheses because that power is attached to the entire -3. It says that, you know, to the 3 and the negative sign. -3 to the 3rd power is -27. And then power raised to power, we multiply, you get x to the 3rd. I mean, we could have just said you attach it to the x and you get x to the 3rd. I just wanted to show you it's the same thing as a power raised to a power. 1 times 3 is 3. This is the answer. Just like we did here. 4x to the 4th, y to the 4th. In reality, there's a 1 there, and we're multiplying it. Power raised to a power 1 times 4 is 4. They give us quite a bit of examples that are similar. This power of 3 attaches to here, and it attaches to here. So the power of 3 attaches to the x squared. See, I can't just put a 3 there. That's why I put it in parentheses. There we go. And then the power of 3 also attaches to the y9. So when it has a power already, you have to put a parentheses there. And so a power outside of a parentheses attaches to each item in the parentheses. And don't forget, when you have a power raised to a power, you multiply. So this is x to the 2 times 3 is 6. You multiply. Power raised to a power, you multiply. And this is my answer. Power outside of a parentheses, in reality, attaches to each item. I mean, you could just put this straight in your calculator, by the way. Put it straight in your calculator. Well, let's just do that. Any number to a power you can put straight in the calculator. So I'm going to, and do you see how this is in parentheses? Put your parentheses in there. I'm going to hit parentheses, fraction, 4 on top, 7 on the bottom, close parentheses, and then raise it to the power of 3. When you put it in your calculator, this is what you get. Did everybody get that? I just want to make sure you typed it in correctly. You should get 64 over 343. So I typed that into my calculator. By hitting parentheses, then the fraction. I forgot what it was. 4 over 3? I don't even remember it. Oh, wrong parentheses.
It was 4 over 7.
Okay, thanks. And then you raise it to the 3rd power. And that's what we got. So practice this calculator. I hope everybody has a calculator now that they're very comfortable with. You should have a calculator that you're very comfortable with. And you practice with it. Okay, number 13. Power outside of parentheses attaches to each item in the parentheses. The power attaches to the top and it attaches to the bottom. It attaches to each item, b to the 4th, and the power is going to attach to it. Remember, power raised to a power, you multiply, so we have a to the 12th. And power raised to a power, we have b to the 16th. 4 times 4 is 16. You can't do anything with the a and b because they have different bases. If they had the same base, you could subtract them. But they have the same base, so we leave it alone. I mean, they have different bases, so we're done. Okay. Everybody get ready to type something into the chat box. What is the answer to number 14? Type it into the chat box. I want to see who's awake. Oh, see, we already got a couple of wrong answers. Now put it in your calculator. 12 to the 0 power. 12 raised to the 0 power is 1. Any number raised to the 0 power is 1, equals 1. I'm setting you guys up here in a second for failure. Okay. In your chat box, type the answer to number 15. Type the answer to number 15. Oh. Oh. Is everybody copying everybody else? What if the first person was wrong? Or are you using your calculator? But didn't I just say up here, any number raised to the 0 power equals 1? But there's a rule about exponents. There's a rule about exponents, and I don't know if I mentioned this last week or any other week. This exponent only attaches to the first thing it can touch. It's touching the 11. So this is negative 11 to the 0 power. 11 to the 0 power equals 1. That's why this answer is negative 1. That's why this answer is negative 1. So put both of these in your calculator. Negative 11 to the 0 power, like I said, and then negative 11 to the 0 power. Put both of these into your calculator. We already said this one gives us negative 1. The reason why is because that 0 only attaches to the 11. Only the 11 gets the 0 power. And this equals 1, but there's a negative sitting in front of it. That's why your calculator says negative 1 for this answer. This one, the 0, the first thing it touches is the parentheses. So the whole parentheses, including the negative sign, everything is 0 power. And I already said anything to the 0 power equals 1. So this one equals 1. When the 0 is attached to the parentheses and there's a negative in it, everything is the 0 power. So that equals 1. So, I mean, hopefully you put that in your calculator and tried it. The top one doesn't have a parentheses. And that's why it equals negative 1. This one does, that's why it equals positive 1. So if we look at this number 16, the 0 power is attached to the parentheses. Everything in this parentheses is 1. Negative 5 to the 0 power is 1 when you have the whole parentheses. But there's still a negative in front of it. So the answer is negative 1. And you can try that out by plugging that into your calculator. Negative, parentheses, negative 5, close parentheses, raised to the 0 power, you should get negative 1. This, once again, the 0 attaches to the first thing it touches. It touches the whole parentheses. So that equals 1. But there's a negative in front of it that 0 didn't attach to. We still have to attach that negative to the answer. Really important that we understand that. Wait a minute. Both of yours say -1 for this, Matilda? Can't be. Try the parentheses again.
No, sir. It was for 15.
Yes, yes. Okay.
I haven't put 16 in my calculator yet.
Okay. Yeah, okay. No, no, I thought you were talking about both of these, the -11 to 0 and parentheses -11 to 0. There's a difference between those two. Okay, so the next one you can't put in your calculator, number 17, because it has an X. So you have to know the rules. The 0 attaches to one thing. It attaches to the X. So only X is to the 0 power. We know X to the 0 power is 1. The -2 is multiplying times the X. You see, right between the -2 and the X is multiplying, invisible multiply. X to the 0 is 1. So this is -2 times 1. The answer is -2. I wish I didn't write too much on this. Once again, only the X is attached to the 0, the first thing it touches. The 0 is attached to the parentheses. So the whole parentheses to the 0 power, anything to the 0 power equals 1. I think these are tough. There's so many different rules. You got to look at it. You got to look at what is the 0 attached to, you know. It can only be attached to one thing. Number 16, it's attached to the parentheses. So only the parentheses has a 0 power. And so anything to the 0 power is 1. There's a negative in front of it. Let's move on down. Stop me if you have questions. Please work on that homework. Number 19, write the expression with only positive exponents. In other words, you cannot have an answer that looks like this. You cannot have a negative power in an answer. Write the expression with only positive exponents. You cannot have an answer with negative powers, okay? Negative powers are not allowed in your answer. The negative powers can be in the problem, but can't be in the answer. If you have a number to a power, put it in your calculator. 4 raised to the -3 power, the answer is 1/64. We're done. I want to show you mathematically how to do it also, but I mean, if you have a number without an X or anything, raised to a power, put it in your calculator. Remember, we said negative powers, you flip. 4 to the -3, you use that, you flip. 4 is really 4/1. So if we flip it, now I have 1/4. The power of 3 is still attached to the 4. The negative vanishes. Remember, it disappears. Once you flip it, it disappears. And 4 to the 3rd on your calculator is 64. So the answer is 1/64. Let's put this one in our calculator. Parentheses, -3 raised to the -3 power. I get a -1/27. I mean, when I look at it, -3 to the -3, the negative is attached to the whole parentheses, so you flip it. -3, when you flip it, is negative 1 over 3. The sign's still there, right? 3 over 1 changes to negative 1 over 3. And the 3 is still attaches to the 3. This 3 is still attached to the 3. And 3 to the third is 27. So it's nice if you just have a number to a negative power, because you can plug that in your calculator and get the answer. You can get the answer here. I'm not going to use my calculator, but I want to show you how we get this answer. Don't forget, 8 is 8 over 1. So the negative power only attaches to one item. I can't stress that enough. People mess this up so much. The negative power only attaches to one item. It's attaching to the 8, not to the negative. So only the 8 gets flipped. It's 1 over 8. The 2 is still attached to the 8. The negative sign disappears. Once you flip it, the negative sign disappears. There just happens to be a negative in front of it also. So we put the negative in front. And 8 squared is 64. So my final answer is negative 1 over 64. So if you put this into your calculator exactly as you see it without a parentheses, negative 8 raised to the negative 2 power, you get negative 1 over 64. Number 22, you can't put in your calculator because we got x's. But it's the same thing. We're flipping the entire parentheses. So 4x over 1 is now 1 over 4x. The power of 3 is still attached to the parentheses. And when you have a power outside of a parentheses, it attaches to each item in the parentheses. Don't forget about that rule. And 4 to the third power is 64 x to the third. You see, 4 to the third power is 64. 4 times 4 times 4. So this is what the final answer would look like. Please practice these. Don't wait until the weekend. Start on this homework tomorrow, tonight. I'll probably give you an extra hour here tonight. Make sure you work on this homework. Don't wait. As soon as you can, and then you'll be able to study. Is there only 23 questions? Last question of the section. Hey, by the way, this is a number raised to a power. I can put this into my calculator. Any number without an X or anything, I can put it in my calculator. But I'm going to go ahead and look at it. Negative power says flip it. And we're flipping it. So now it becomes 7 over 4. The 4 stays attached to it. We flipped it, and the 4 stays attached to the parentheses. So we have 7 to the 4th and 4 to the 4th. I think that's 256. I don't know what 7 to the 4th is.
2,401.
Thank you. So there's our answer. And this was, once again, the end of exponents section. It's like a combination of 2 sections, just the exponent part of it. And there's a homework labeled this. section R3/R6 exponents.